Hello, thank you for joining to the presentation about enhancing IoT security. My name is František Arbata and I am working with Espressif in the IDF tools team. And one of the tools that I would like to introduce you today is esp-idf-sbom. First, I would like to talk about software bill of materials in general, some basic information, what it is, what is it good for, about how it's represented in for application generated by esp-idf framework. Then I will be talking a little bit about manifest files. So these are files that are the key source of information for the resulting manifest. And later on, I will be talking about the tool itself. It's called esp-idf-sbom tool. And the last part is a demo I prepared, but it will not fit into the presentation's time frame. So I will leave it in the slides. The slides will be available after the presentation. So if you are interested, you can take a look at the demo later. At the beginning, some basic introduction to the software bill of materials. So you can find a lot of formal definitions on the internet. I like the analogy to a list of ingredients on a food package. So you can think of SBOM as a list of ingredients for a food package, but instead of ingredients in food package, just think about libraries and components. In reality, it's actually not a list, it's more a directed graph, but the analogy is pretty nice. So what is it good for? Why do we need SBOM? First is probably the transparency. The same as you go to the grocery store to buy a snack, you can check out on the package list of ingredients. The same if you want to deploy or use some application, you can check out from which libraries, components it uses and check it out. For example, if you are allergic to peanuts, you will not buy the snack. The same if the software doesn't comply with your license policy or requirements what software can be used in your environment, you will not deploy it. Other huge advantage is you have an inventory and you can quickly scan for possible vulnerabilities in your product. It's not only for customers, but also for the vendors, when they can, for example, continuously scan the software they are providing if new vulnerabilities arise or not. And it should allow much quicker time response and in case some new vulnerability turns out. And last but not least, there are some government regulations. In US, it's executive order, which is already in place, and SBOM is actually recommended to be used in all federal institutions, but Food and Drug Administration requires it. It's mandatory for the medical devices. In the European Union, we have the Cyber Resilience Act. It was approved, finalized, and it should be enforced by late of 2025 in the first phase. In both of these regulations, the SBOM plays a critical part. So that's in a nutshell why the SBOM is needed. It's useful and it's also required. There are basic three major formats. Software package data exchange. This is maintained by the Linux Foundation. And this is also the format used by esp-idf-sbom to generate SBOM file for esp-idf projects. There is Cyclone DX and software identification. These are the three major. And we decided, or currently we are using the SPDX format. In the SPDX format, each component, aka library, is represented with something which is called in SPDX terms SPDX package. I will be talking a little bit more about it later. So what are the minimum requirements? We based our requirements on the National Telecommunications and Information Administration, and they specify in the document you can find in the slide the bare minimum what each component or library within the SBOM should contain. First, it's the supplier name, who supplies the package. Component name, its version, some unique identifier, and dependency relationship. This is important because this plays a key role in the software supply chain. So this is one thing I forgot to mention about why is SBOM good or needed. Through the relationships, you can see the software supply chain. Then the author of the SBOM, the document, and some timestamp. That's basically all that is required from the NTIA. There are plenty of tools you can find. Since we are using the SPDX package, the SPDX page contains a list of open source and commercial tools. Also has some nice online tools. For example, the NTIA checker, where you can take the SBOM and check it if it complies to your the regulation or the bare minimum information that should be in the SBOM. Also, I would like to mention by SPDX tools, which I am using for verification and validation of the SBOM. It can be used to convert the SBOM into different formats and generate the dot files that can be visualized. I will show you a little bit later with this graph, for example. So it's good to know about it. And now I will be talking about how the SBOM actually looks like within esp-idf or for the esp-idf application. We are using the SPDX format, as I already said. We are using very simple tag value, but there are multiple flavors or other formats that can be used, like JSON, YAML, or XML. Again, using the online tools, you can convert it to any format that you prefer. We are using a single file representation, meaning the whole SBOM is in a single file. If I compare it, for example, to Zephyr, they are using multiple files to represent the SBOM. And as I said at the beginning, the SPDX format or the SBOM in SPDX format is based on SPDX packages. And since esp-idf project is like a composition of components, this nicely maps into the SPDX package definition. So we represent basically everything as SPDX package. I will be talking about this a little bit more, but it's, the relationship is important. Like component is SPDX package. I will probably mix the things during the presentation. And the tool, which is esp-idf-sbom tool, is by default creating SPDX package for each component in the build and for each submodule it founds automatically. And this could be enhanced by additional SBOM files, which can create sub-packages in the component. So maybe, for example, let's say in esp-idf we have a console component, and the console component contains arctables, a library, and line noise. So it would be nice to express this relationship in the SBOM. Like there is not only a component called console, but the console component itself depends on two different libraries. So esp-idf-sbom allows to express this relationship. This is how it looks like, a high-level overview within the SBOM, within the generated SBOM for esp-idf. We have the document. It's SPDX document. It's mandatory. It's the main part that describes the whole SBOM in the SPDX format. And it describes our project. You can imagine it's a Hello World project. And the Hello World project depends on multiple components. And the components themselves could depend on other components or the submodules or the sub-packages which are created based on the manifest files, which I'm going to be talking about a little bit later. The default layout, by default, all the components which are part of the build are included in the SBOM, but only components directly linked to your project are in a relationship with it. Meaning, for example, here you can see this component is not related or in any way to the project. Meaning, for example, embed TLS is part of the build for whatever reason, but it's not actually linked into your project. It will still by default be in the SBOM, but it will not be linked into the project. The reason is it's part of the build, so it should probably be mentioned, but it's not linked. And this is an important thing because esp-idf-sbom tool comes with its own security checker or vulnerability checker. And it actually works that it goes through or transition through the tree with root of the project, like hello world. So if the component isn't reachable for a project, it will not be scanned or reported. This is actually how the SBOM hierarchy or its directed graph looks like for a Hello World project. This is actually generated from SBOM file with tooling. I think it's called SBOM2.dot. And this is how it actually visualizes the structure of the SBOM. Now, I would like to talk a little bit about manifest files. This is a key source of information in esp-idf to generate SBOM. The esp-idf-sbom tool is trying to some degree to figure out the default information. For example, it generates the component name. It also tries to figure out the version, the supplier to some degree. But sometimes it's necessary to explicitly state the information. You can state, for example, explicit license for your component or copyright for your component, or you need a different name. So this is when the manifest file comes in. Manifest file can be located at your root, at the project, or any component level. It can be in some module, and it can be in any subdirectory of the submodule. If it's found there, the esp-idf-sbom tool will create a SPDX package for it, and it will be correctly linked into the hierarchy, into the supply chain, if you want to. It's in a simple YAML format, and the main file, which is looked for by the esp-idf-sbom tool, is sbom YAML. But the information can be also provided within IDF component, which is a manifest file for components in component managed by component manager, and also directly in Git modules. I will show you examples how it may look like. Now, what can be specified in the manifest file? Of course, there are the required things like name, version, some description, repository, URL. This is, if available, a link, for example, for tarball, for the specific version of the library. CPE is a crucial thing. We are using it for vulnerability scanning. CPE stands for Common Platform and Common Platform Enumeration. It's unique naming used by National Vulnerability Database. And it uniquely identifies a library or some other piece of software. And with this string, you can ask NVD or check against the National Vulnerability Database to see if your product or component or library is vulnerable to some CVEs. How it works, if there is a new security issue, the new common vulnerability and exposure is created, new CVE is created. Then NVD takes it and adds some additional information. They are doing analysis, and one of the things they are adding into the CVE information, which is kept in the database, is the CP. They identify the products, exactly the products which are vulnerable. And this is what we are using to check for possible vulnerabilities in esp-idf-sbom tool checker. Supplier, it's who is distributing the package, and originator is the original author of the package. Maybe example, for example, esp-idf is using FreeRTOS, and the FreeRTOS component contains copy or adjusted copy of FreeRTOS operating system. So the originator is Amazon Web Services, but the distributor is Espressif, the supplier. Then you can specify a hash. This is a hash that records the state of the sources in the Git tree, and we are using it to make sure that the information in manifest file is up to date with the sources. For example, you can upload a new version. It may be subtree, Git subtree, it may be submodule, you can just copy it there. But in Git, it will always get a new SHA. And we are using this to check if the information is up to date within the manifest file. This is done through some pre-commit hook and in our CI when we are checking if the hash in manifest file matches the hash in Git tree. You can explicitly state the license, copyright, and there is an exclude list. What it is used for. Let's say you are using some library and there is a new vulnerability found and reported by the checker. But after you analyze it, you will find out, okay, I am not using actually this function, so this CVE is not related to my product or my application. You can just mention it there. It will be also recorded in the SBOM file, and the checker will ignore it. It will not be reported as a vulnerability. It will be a special section which is marked like excluded CVEs. Manifest files. This can be used to express a relationship with other parts in your component in case you cannot add the SBOM file into the directory for it. So, for example, let's say I have a component which depends on some upstream component and upstream library, and I have no way how to add my file, my SBOM file, my manifest file into the upstream library. But I want to express the relationship my component is using this library. So this is where you can use this manifest file. You can state like you can create the manifest file for the library and say in the main SBOM manifest file, okay, this manifest file belongs to this directory, and it will treat it. The IDF SBOM tool will treat it as if the manifest file was actually placed within the directory, in the libraries directory, and create the proper package hierarchy. The same goes for virtual packages. I don't think we are using it right now, but the idea is to describe a relationship when your application or the firmware is using something from ROM. It's not actually part of your application, but it's a real-time dependency that you want to express. And there could be an if condition which can use all the kconfig options from your project configuration. And if evaluates to true, the sub-package is included. If to false, it's skipped. So you can conditionally include, for example, information about libraries based on configuration if they are included or not. This is an example. It's not a real-life example for the FreeRTOS manifest file. You can see the name version. Here is the CPE string. The curly brackets are just placeholder, later replaced by the version. And here we can see that the supplier is Espressif and originator is Amazon Services. Some description. Here we have the hash to check that if the maintainer of the FreeRTOS component uploads a new FreeRTOS version, he will not also forget to update the manifest information. And here we have example of the excluded CVE list, because this CVE is related only to ARM CPU, ARM architecture. It's not related to Espressif, because Espressif is not using ARM architectures, Extensa and RISC-V. This is just an overview how the information from manifest file is mapped into the SPDX file, into the package in the SPDX file. And here we can see it. Here you can see how the information from the manifest file is propagated there. Again, name, version. You can also maybe note this is no assertion, it's a valid value in SPDX file tag format, and it means the tool didn't make any attempt to figure out what is the correct value. For example, here we haven't even tried to figure out the licenses. Now an example how the SBOM information can be included in component manager for manifest file for component manager. This part is related to component manager, and this is for the SBOM. Just you can see there is a new dictionary SBOM, and you can put everything there. Maybe one thing, if for example the version isn't part of the SBOM, the tool looks for the version in the IDF component YAML file. The reason for this integration is that there is probably no reason to have two files, having IDF component YAML file and SBOM file at the same level describing same information. And the manifest information can be also specified directly in Git modules. So you can see it's just different format, but express everything what is needed. Now I will finally talk a little bit about the IDF-SBOM tool, which is the tool that actually generates the SBOM for esp-idf projects. It also contains a vulnerability checker, which can be used, and other commands, which I will briefly mention a little bit later. So you can find hopefully much more information at the GitHub pages, and there is hopefully enough information in the documentation. It's not integrated into esp-idf yet, but it should be working with all latest releases of esp-idf. So you can install it through pip, and you can invoke it with esp-idf-sbom console script, or which may not be in the path by default, so be careful, or directly as a Python module. So the only information that the esp-idf as input, the only information that esp-idf-sbom needs as input is project description JSON. This file is generated during the build, and it contains information about components which were part of the build, and also like path to link file and other information. But the only thing that is needed as input is project description JSON. Through project description JSON, the tool can figure out the components which are part of the build. Based on the components and their path, it can figure out the sub-packages and sub-modules and put it all together. So these three parts are creating the package hierarchy in the SBOM. A link map file is used to figure out which components were actually linked into your application. As I mentioned previously, only components linked into your application will be directly linked or related to the project SPDX package, which describes your application in the SBOM. And these are the three sources for the information for the manifest files or manifest information, and the result is generated as well. So the level of detail in the SBOM depends how you invoke it. By default, as I mentioned multiple times, is that it contains all components that were part of the build, but only components linked into the project are related to the SPDX project, SPDX package, project package in the SBOM. If you, for example, want to add information about licenses, you can do so by file tags. It will scan the sources of each component, and it will look for SPDX file text, and it will gather and add a concluded license. Of course, the licenses, the SPDX file text need to be present in the sources in order to find them. And you can also add the files, meaning there in the SBOM, not only information about the package, about the component, can be also, there can be also files. It can be listed all files within the component. Generating such a SBOM takes some time and it's much bigger. So this is not the default option, but it could be added. And this is example how it looks like. It's just the beginning of the SBOM for the hello world. Here we can see the SPDX document. And we see it describes our hello world project. There is some information filled by esp-idf-sbom, the default values. If we had a manifest file within the project, hello world project, we could specify, the name we want, the version we want, and other information, license, copyright, whatever is possible to express in the manifest file. And here we can see the relationships. You can see that the project depends on these components, and the output is stringed, of course. So if we saw the whole output, we would see a SPDX package for each of these components, and each of these components would have dependencies on other components. So this is just for an example. Now, checking for vulnerabilities. As I explained earlier, this is based on Common Platform Enumeration, which is provided in the manifest file and transferred into the SBOM. It is using National Vulnerability Database REST API. There are some limitations, like number of requests, there are some timeouts and recommendations, and you can query NVD REST API only for a single Common Platform Enumeration, CP or CVE. You can simply check the SBOM by running esp-idf-sbom check, SBOM check and the SBOM file. There are other options, but you can find more information on the GitHub manual, in the GitHub documentation if you would like to. Here is some example of a report. In the beginning of the report is like report summary, where you can see the overall result. Here we can see that 3 CVEs were identified for the FreeRTOS package. And the report summary is followed by detailed information. Again, just example for the 3 vulnerabilities found above. For the FreeRTOS, here you can see there is also a description and severity and base score of the CVE. Now, lately there are some issues with the National Vulnerability Database. The first thing is they are a little bit behind and have a huge backlog of unprocessed CVEs, meaning such CVEs do not have the CPEs, which identifies which products are actually vulnerable. But in their announcement, they promised or stated that they will deal with this till the end of this year, so it should be fine, hopefully. And the second issue, lately we can see that the availability of the REST API is very problematic, but in last few weeks it's working pretty well. I will be talking a little bit about this later. The tool itself, the IBM SBOM tool, can be used to generate also some license and copyrights report. The information about licenses and copyrights could be within the SBOM file if required, if needed. But you can use it. The IDF SBOM tool can be used also just to generate some overall information about the licenses for your project. One more thing I would like to mention about this is the esp-idf-sbom does also work directly with manifest files. What it means, you can put list of manifest files or directories to its input, and it will just go through all of them and validate them, check them, and or generate the licenses report. So this is something that we are using, for example, in our CI for checking our repositories for possible new vulnerabilities, or if all the manifest files are valid. And this is just some helpers. We are using a pre-commit hook. We just check if this is part of the esp-idf-sbom. You can see the details on the GitHub. We are using it to validate the manifest file, and if the hash is provided, as I was talking previously, it can verify that the manifest information is up to date with the source code. And we have a vulnerability scan action, esp-idf-sbom action, again available on the GitHub, and it scans all our repositories, meaning esp-idf all branches currently supported, IDF extra components repository for component manager, and it's sending us a report to our internal Mattermost channel. So we are checking and monitoring possible new vulnerabilities in our repositories. And for the future work, we are planning to improve the vulnerability scanning because of the recent problems with the NVD REST API. The idea is to maintain our own copy of the relevant national vulnerability database entries in a Git repository and implement our own CPE, name matching and applicability language, and do the scanning locally. Hopefully it will be much more reliable and faster. This is currently work in progress, and it's looking good. Also working on our documentation, we are planning to add information about esp-idf-sbom into our programming guide. And one other thing that may be worth mentioning is GitHub action for scanning the project vulnerabilities. Now we have GitHub action for scanning the whole repository, but this will be per project. If you have any issues, suggestions, comments, or pull requests, please leave a message note at the GitHub pages. We have issues, discussions opened. Pull requests are always welcome. So any feedback. Thank you. And this is the demo, which I will skip. And if you are interested, you can check it out later once the slides are available. And that's all from me. Thank you for watching and have a nice day.